morning, good afternoon, and good evening. Welcome to Chapter 3. Chapter 3, we're going to continue to discuss chemistry. Can I see the excitement in your faces? In Chapter 2, chemistry, we talked about chemical bonds. We talked about how different atoms will attach to one another, covalent bonds, polar covalent bonds, ionic bonds, hydrogen bonds. Now we're going to talk about different varieties, different classes of molecules. Because this is biology, we're going to talk about organic molecules. Organic molecules are things that consist of carbon and hydrogen. You may have ever watched a sci-fi TV show that talks about carbon-based life forms. You are a carbon-based life form. You use carbon as your primary atom. Chains of carbon as your primary backbone molecules for building your body. One important thing to note, we did talk in Chapter 2 that water is absolutely vital to life as we know it on Earth. Water is not organic because if it's organic, it has to contain carbon. What's the formula for water? H2O. There's no C in H2O. So water is inorganic. Here we see some organic molecules. Obviously, we have a male and a female lion up here. What I want to show you is that these two molecules are hormones. This is specifically testosterone. You recognize that one. Estradiol, you probably don't recognize, but you've heard of estrogen. This is one of the estrogens. So what we see here is what's called the simplified version of notation. When drawing organic molecules, they get really big, really complicated really quickly. And it becomes a chore to draw all of the atoms that go into making a particular molecule. And so organic chemists developed a shorthand. This shorthand is called simplified. At each of these angles, you assume there is a carbon atom at each angle. The line between them means that this carbon is linked to that carbon. And there will be hydrogens and probably some oxygens also attached at various places to each of these carbons. Though at an angle, any given angle, it's going to be a carbon there, and there will be some other stuff attached to it. So that's what we see. That's what this means, and we'll talk a little bit more about that later on in the chapter. The last thing that I want you to notice is, look at how similar the male sex hormone is to the female sex hormone. This bit is identical. This bit is identical. We're just missing a little what we call a methyl group. This is a methyl group. And then this alcohol group replaces this single oxygen. Aside from that, these two compounds are the same. These two compounds make the difference between male and female. And look at how similar they are. There are four biologically important molecules. The first and most important molecule to life is water. After water, it is these four molecules, these four organic molecules. So we would call these the four biologically important organic molecules. Carbohydrates, lipids, proteins, and nucleic acids. These are the four biologically important molecules. We'll talk about each one in turn. They all have some similarities. The similarities is that they're all what we call polymers. Poly means what? Poly means many. A polymer is an object that is made, or a molecule that is made from several repeated smaller units. And the example is a literal chain. A chain is a bunch of links connected to each other. A bunch of repeated units. That's what a polymer is. A polymer is a bunch of smaller things all connected to each other. And all of those smaller things are very similar, if not identical. All of these links are very similar, if not identical, to each other. This link is the same as that link. So a polymer is made of monomers. Poly means many, mono means one. Those monomers are the building blocks. So in my chain description, a single link is the monomer. I put a whole bunch of them together, now I have a polymer. These separate molecules are all bonded to each other, and we'll look at some of the bonding when we get there. The way we link together the monomers to make the polymers is called dehydration synthesis. What does dehydrate? If you're dehydrated, what does it mean? Well, it means you don't have enough water. So dehydration means to remove water. Synthesis, synth, means, it doesn't mean fake. It doesn't mean artificial. It does mean created. So something that is synthetic has been created. It's not found naturally. So synth means to make or to create. And so dehydration synthesis means making things by removing water. I remove water molecules, and I'll show you how this works in a bit. You remove water molecules from these two separate molecules, and then we link them together by removing a water from between them, and I'll show you how that works in a bit. If I remove water to join them, then I use water to break them apart. Hydrolysis, hydro again means water, lyse means to break. So hydrolysis means breaking using water to break something apart. The way both of these tasks are accomplished is by using special molecules called enzymes. We'll talk a lot about enzymes throughout this whole semester. The short answer, the short definition for what is an enzyme. An enzyme is a special molecule. It is a special tool that has a special job. The job is always to make some reaction happen. There are a bajillion different reactions that have to happen inside your body, and so therefore you have a bajillion different enzymes whose job it is to make those reactions happen. And again, we'll talk about enzymes as we get deeper into it, deeper into the chapter and deeper into the semester. But the short answer again is that enzymes make reactions happen. They're a special tool that allow a special reaction to occur. What special reaction? All of the reactions. All of the reactions in your body have a particular enzyme that make it work. And it's not one enzyme makes everything work. It's that there are a bajillion reactions, and therefore you have a bajillion enzymes. Each one has a particular job to make one particular reaction occur. This shows dehydration synthesis. Here is a short polymer. Each one of these little pearls represents a different molecule. Notice that at the end of my little pearl right here, it's got one of those little alcohol groups, OH groups. This is a monomer that's not attached to anything. It's got my little alcohol group over here on the side, and it's got a little hydrogen right here. I take the hydrogen off of this one. I take the alcohol group, the OH group, off of that one, and I link them together, and that's how I make water, H2O. And where those bonds used to be attached to these two molecules, I now just make that bond between those two. I have 1, 2, 3, 4. I link the fourth one on. Now I have 1, 2, 3, 4. All right. Dehydration synthesis. I remove a water molecule from between the two, and then I make a link where those two pieces had been. Dehydration synthesis. You remove water from it. You actually make about 10% of the water your body needs. 10% of the water your body has to have. You don't drink it. You make it. You make it like this. If I remove water to link things together, then I add water to break them apart. And this is just the same graphic in reverse. Here is my polymer. That's 1, 2, 3, 4 pearls up there. 1, 2, 3, 4 molecules of something. I take a molecule of water, and I use it to split apart that bond right there. I split this bond where it was. I put the pieces of the water in its place. I put an OH group, an alcohol group on the one. I put a hydrogen on the other. I've now split apart my polymer and made a monomer and a shorter polymer. And I could use more molecules of water to completely break this polymer down into its 4 separate component pieces. These 4 separate monomers. It might be that this is an amino acid. In the case of breaking apart proteins, it could be that this is a sugar ring in the case of breaking apart carbohydrates.